Hello, my dear students, myself Ryan Gandhi. In the previous video, we have discussed about the construction and the demonstration of the impulse turbine. We are now consider the experiment of this turbine. The aim of the experiment is here to find the performance of the turbine and the efficiency of the turbine. So from this aim the experiment, we have to first of all required apparatus required. One is a testing of an impulse turbine and a tachometer, and fill up the water at 3/4 of the tank. Then after we will go the procedure. Now we will go through going through the impulse turbine. Now this is your impulse turbine. Test 3. Here is a 3/4 of water is there for experiment view, and this is your spring loaded balance. This is a spring loaded balance. You have to put load here. This is your in a 0 position. Some error are there, but this is in a 0 position. And this is your pump. This is your pressure gauge inlet and outlet pressure gauge for a through the flange from the pump to the turbine section. Here is your orifice meter where we have to control the flow. In a way also we started in the previous video. This is your pressure gauge which will be indicate that how much of pressure should be go through the turbine. And this is your turbine section. After on that we have turbine, we will go through the nozzle. It is a tangential flow type. So here with tangential it will be flow the water should be flow in the tangential way and rotate the runner through the bracket. Now switch on the 3-phase connection. We will start at the experiment. From the above experiment, we have find the data of RPM is equal to 660 and the pressure gauge difference of a P is equal to 20 kg per cm square, and the difference between P1 minus P2 is 2.2 minus 2.1, and this is your dead weight balance is your 2 kg, and is a spring difference is your 0.5 kg. Now how it will be contact with the bucket. Now this is the view of a Pelton wheel turbine. Here is the view. You go through the penstock. We are not here a penstock, but we are the pipeline. Through pump we uses this. So through this, the through nozzle will strike tangentially to the turbine blades. That is your vanes, or you can call blades. It will be rotated. Then after we will generate the output power. Now how will we find the efficiency? So finding the efficiency of a turbine, efficiency formula equal to your input power output by input power. So here input power is your water power, which is equal to rho g q h, whereas q is your discharge and h is your head. This is the input power, and output is your the shaft power. Also you can write, because this is a shaft, there is a torque is generated here, so you can write 2 pi nt by 60, but you cannot find the torque in this way. That's why we consider here the weights. So you can write 2 pi n spring balance load, difference of the spring balance load in the given load into the radius of the dynamometer. by 60. So this is the input, this is the output. From this we have to find the calculation from this above reading. Now first of all we have to find the discharge. So Q is equal to formula is here, Q is equal to CdA root 2 GH. So here is a pressure difference is there, that is a P1 minus P2. We can consider that is DH here, and we can write CdA 2G DH to the power half. So coefficient of discharge is a constant, area is also constant, and you have the G is a gravitational constant, DH is your P1 minus P2 value is your DH. From this you can find the P1 minus P2. From this you can find Q value here. Then H is your height, inlet height. Height is your given here, the total height in a pressure gauge is your 20. So 20 in your kg per centimeter square. So you can write 20 into 10 meter. This is also you can write P1 minus P2 in a kg per cm square. This is also into 10. It will convert into meter. So you have to find rho G Q here. Then after you have to find W minus W to R. So brake power is here or shaft power is here. 2 pi N is given there 660. And load is here given there W1 minus W2 is here 2 minus 0.5. Spring load balance. This is in a kg. You have to convert it in a Newton. So kg into Newton means G is equal to 9.81. You have to multiply 9.81 into radius is your given radius is your the diameter of the brake drum is your 22 centimeter. You have to find meter is your 11 centimeter or 0.1 meter. So from this you have to find output power. From this you have to find input power. Okay, so first of all calculate this input power, putting the value all of you for input power. So first of all find the CD, A and 2GH value. First of all, pause. For experiment turbine input is your rho G Q H. So this is your G value. You have to find Q value is your 0.0246. Height is your 20 meter and 9.81 is a Newton per meter square. 1000 is your water density. Now you have to find 4838, that is the value is 4.8 kilowatt. The input power is your 4.8 kilowatt. And turbine output is your 2 pi NT by 60. The value is your 1097.47 watt and the output value is your 1.09 kilowatt. Now efficiency is equal to output by input. Now 1.09 by 4.8. The value should be 0.227, that is 22.7%. The efficiency is your mechanical efficiency is your 22.7%. Now your efficiency to find this observation, the value of efficiency 22.7%. You have to know from this section you have to find the value. In this way you can find number of experiment there, and you have to different reading you can find different value. Okay, this is your efficiency value. Now we will be done the job.